And then let's also check the audio 1 to 10. Great. Okay, very good. So before we start the recording, let's take a look at what we'll be covering today. We'll finish section 4.4. That's going to wrap up chapter 4. Then we do have a note to discuss regarding 4.1 and exam 2 reminders. So I sent the exam 2 reminders this morning right before class. And then we will start chapter 5. So the chapter 5 and 6 lecture notes are already in Canvas. So if those 2 modules, chapter 5 and 6, have been published. Okay, so that's the plan. And then after exam 2, we will be continuing in chapter 5. And in our remaining 2 weeks, we have chapter 5 and 6. Then we would have completed the material for the course. So let's go back here. Okay, and we'll start the recording. Let's see who we're missing. Stephanie, I received your message. Thanks for letting me know.
Recording in progress.
This recording will cover section 4.4 continued. So we'll be looking at the last page of section 4.4. Okay, so let's start by recapping the previous problem. When we're solving these trigonometric equations, our step 1 is to isolate a single trig function. So if your trig equation contains more than one trig function, you need to use the identities from chapter 3 to write the equation in terms of a single trig function. Then your equation, you may be working with linear function or quadratic function. Use your algebra skills to isolate the trig function. Okay. After you've isolated the trig function, if you find that your input is on the unit circle, then you need to provide the degrees or radians in exact form. If your input is not on the unit circle, then you'll use your calculator to find the input by using the inverse trig function. The inverse trig function will only provide one answer in a restriction. So when we take inverse cosine to get x1 and x3, we only get the answers that are between 0 and pi. That is the restriction for inverse cosine. To get the other solutions in quad 3 and 4, we have to use the symmetry for cosine. So for cosine, we do 2 pi minus inverse cosine to get the other solution. And then for sine, we would do just pi minus first solution to get second. Okay, so once we generate all the solutions in the first cycle of our trig function, then we can add period times k to each solution to write all solutions for the equation. So that was a 3-step process. Isolate trig function, find the solutions in the first cycle of the function, and then add period times k to each solution. The added step 4 we learned yesterday was if your x, or if your input is not x, then your added step 4 would be to isolate x. So we saw that in section 4.3. Another note is if they're looking for specified solutions, we've said this before, first find all solutions and then get the specified solutions. So in this problem here, it says find all angles between 0 and 360 degrees. So you want specified solutions, and we are in degrees. Those are the pre-steps, our seatbelt step. Okay. Then let's put a reminder here that we want to first find all solutions, then specified solutions. Okay. So with this equation here, we have both sine and cosine in the equation. Let's use our Pythagorean identity. We can rewrite sine squared of x as 1 minus cosine squared x. And then with quadratics, we may want to apply our apple banana method by substituting cosine of x with a. So now the equation will read 1 minus a squared is equal to 0. In order to isolate our trig function, we need to solve for apple. So we have 1 minus 2 apple squared is equal to 0. So that means 1 is equal to 2 apple squared. Let's isolate apple. Apple squared is equal to 1/2. So apple is plus or minus 1 over root 2. When you're taking the square root of both sides, remember there's two roots, positive root and negative root. Because positive 1 over root 2 quantity squared is 1/2. Negative 1 over root 2 quantity squared is also 1/2. So we have two solutions for A. A comes out to be either, after we rationalize the denominator, A is either negative root 2 over 2 or positive root 2 over 2. Okay, so now we completed step 1. I'm going to bring in students to help us with step 2 and 3. So we have isolated cosine. Cosine of x is either equal to negative root 2 over 2 or cosine of x is equal to positive root 2 over 2. Draw the circles as needed. We know that cosine is the x-coordinate on our unit circle. So we want to find, in this case, the degree measures in which our x-coordinate is either negative root 2 over 2. Sorry, let me just do that one more time. Our x-coordinate is either negative root 2 over 2, which is about here, or our x-coordinate is positive root 2 over 2, which is here. Okay, so let's start with Genesis. Looking at our graphs here, and we'll label these in order. So this is 1, 2, 3, 4. Okay, so let's start with x2 and x3. If they're on the unit circle, we need the exact value. If not, then we get the decimal approximation using our calculator. So Genesis, what are x2 and x3?
3 power 4 and 5 power 4.
That's correct, but we're in degrees. So
135 degrees and 225 degrees.
That's right. Very good. And Jacob, how about x1 and x4?
It would be 5 and 315.
45 degrees and 315 degrees. That's right. Okay, so at these four angle measures, cosine of x is equal to negative root 2 over 2 or positive root 2 over 2. So we have four solutions in the first cycle of cosine. So that means four solutions in the first cycle of cosine are 45 degrees, 135 degrees, 225 degrees, and 315 degrees. Okay, so that was step 2. Okay, Stephanie, please remind us, what is our step 3?
Once we have the x value, then we'll set it up in the equation x plus period k.
Very good. So our step 3 is to add period times k to each solution. And Stephanie, what is the period times k?
That would be 2 pi k.
Correct, but in this problem, we would be
Oh.
adding
360.
degrees times k. Thank you, Stephanie. Very good. Yes. So always check to see if you're in degrees or radians. Here in degrees, our period for cosine of x is 360 degrees. Okay, so we've completed our 3-step process. We isolated cosine. We found the solutions between 0 and 360 degrees. Then we added 360 degrees times k to each solution. So we've generated all solutions. Okay, when the problem is looking for specified solutions, now in the final step, we can list the solutions that are between 0 and 360 degrees. So for this problem, may seem that we didn't need step 3. However, we want to get in a habit of always finding all solutions first and then specified solutions. Because there will be times where when you don't get all solutions first and you jump to get the specified ones, you may end up leaving out solutions or including solutions that don't belong. Okay, so for the last problem in chapter 4, try this one on your own. And we will proceed as we have done previously. Once you start working, please put in a W for working, so you know we're on task. And then when you finish, send your answers to me in the DMs. The hint this time is that you should have 2 solutions. Oh, and let's star this problem for you to go back and review. While you're working on it, I'm going to pause the recording.
Recording stopped.
If you have questions, put them in the chat. Those that are just joining our discussion, welcome. If you have questions as you're working through this problem, put it in the chat so I can help direct you. And then when you're finished and you have solutions for alpha, send them to me directly. Okay, I'm seeing two questions in the chat I want to address with all students. Yes, we do. Oh, we do not need to use the double angle identity here. We can just use the Pythagorean identity to rewrite sine squared of input as 1 minus cosine squared of input. And then remember, when your input isn't x or isn't the variable itself, you can still use the 3-step process to solve for the input. And then the added step 4 is when you isolate alpha. So solve for 2 alpha first, and then your step 4 should be isolate alpha. From there, after you have all solutions, you can then plug in the k values to find the specified solutions. And then another student question is, what side do you start on first? When you're working with quadratic equations, you want to get all terms on one side in order to isolate the variable. So with linear equations, you just directly isolate the variable. Quadratic, get all the terms on one side, factor, and then you can isolate the variable. Students that had sent me the DMs, let me know if I answered your question or if you need further explanation. And reminder, we're in degrees, so your answer should be in degrees. Great. Okay, so let's give this a try for a few more minutes before we bring it together. Okay, let's come together. I see few answers that are on track, but it looks like students may be stuck. So let's first resume the recording.
Recording in progress.
Okay. So when our input isn't just the variable itself, like we have in this case, we solve for the input first using the three-step process. And then our added step 4 is we isolate the variable. So you're going to solve for 2 alpha and then isolate alpha. Okay. So with our quadratic equations, or really with any equation, we need to get the equation in terms of a single trig function. So if we have sine or cosine squared, we can use the Pythagorean identity to rewrite sine squared in terms of cosine and cosine squared in terms of sine. Okay, so we'll start with Justin. What is sine squared of 2 alpha equivalent to?
1 minus cosine squared 2 alpha.
Correct. So the input stays 2 alpha. Okay, and then here I would rewrite the cosine of 2 alpha as apple to help with isolating cosine of 2 alpha. So after you write the equation in terms of a single trig function, you have the option of substituting in for that single trig function an a to help you isolate the trig function. So let's solve for a here. Okay, and with quadratic equations, we want to get all the terms on one side. So we have a squared, this is plus 3a, and then 1 minus 3 is negative 2. So we add 2 to both sides, so plus 2. Okay, so we used our algebra skills to get all the terms on one side, and then now we need to factor completely. Let's go to Miguel. Miguel, did you get the 2 factors here, whose product is a squared plus 3a plus 2? That's right. And the order here doesn't matter. We could do a plus 1 times a plus 2 or a plus 2 times a plus 1. Okay, great. So we're going to set each factor equal to 0. A plus 2 is equal to 0, or a plus 1 is equal to 0, which means our apple is either equal to negative 2 or negative 1. Okay. So we've completed step 1 together. We got our trig function cosine of 2 alpha isolated, and it's equal to either negative 2 or negative 1. When your sine or cosine value is equal to a number that's not in the range for sine and cosine, then you know that that equation will never be true. So right here, you may have caught that, remember cosine, the range for cosine and sine is negative 1 to 1. Therefore, cosine cannot equal negative 2. And if you tried to put it in your calculator and you did inverse cosine of negative 2, you would get an error. Cosine cannot equal negative 2, as negative 2 is not in the range for cosine. So on the first side, there's no solution. Not every equation you're given will have a solution. Sometimes you solve and you get no solution. Here, so the first part is no solution. Let's move this down here. However, the second part, cosine can equal negative 1. Negative 1 is part of the range for cosine. So cosine being the x-coordinate, we see that cosine is negative 1 right here. Okay, so Hector, What is the degree measure where my arrow is?
Sorry, Professor, I had it on mute. It's pi?
Yes, and then, but we're working in degrees. So I put a reminder here that
Oh,
we're in degrees.
180. 180.
Correct. Yes. Okay. So at 180 degrees, cosine of 180 degrees is equal to -1. So completing step 2 of the process, we find that the input is equal to 180 degrees. That's the only solution between 0 and 360 degrees. So this time we only have one solution that's in the first cycle of cosine. We're not looking at the period for cosine of 2 alpha, just the period for the parent function cosine. Okay, so between 0 and 360 degrees, we have one solution. Our step 3 is to add period times k to each solution. So in degrees, we're going to add 360 degrees times k. Okay, so we've taken care of our 3-step process to solve for the input. Then if your input isn't the variable that we're solving for, we have an added step 4, which is to isolate our variable alpha. So to isolate alpha, we need to divide both sides by 2. And alpha comes out to be 90 degrees plus 180 degrees times k. This is an example where if we're not going in the order of solving for the input and then isolating alpha, we may end up missing a solution. Okay. After we get all solutions, that's when we're able to plug in the k value. So we can plug in k equals 0, k equals 1. So let's start with k equals 0. We have 90 degrees. K equals 1 would be 270 degrees. K equals 2, we have 450 degrees. Okay. We only want the solutions between 0 and 360 degrees. So we have here 2 solutions between 0 and 360 degrees. 450 degrees is not in the specified interval. Therefore, alpha is equal to 90 degrees or 270 degrees. We end up with 2 solutions in the specified interval. Okay. So in this last problem in section 4.4, we're seeing the necessity of going in order. Step 1, 2, 3, and then the added step 4 if necessary. Added step 4 is isolating your variable. So get all solutions for the input and then isolate variable. From there, if they ask for specified solutions, you plug in k values to determine the solutions that are in the specified interval. Okay, students, are there any questions with this last problem? We put a star on it. So go back and review the problem, find problems that are similar in the homework and textbook to use as practice. At the end of chapter 4, or really at the end of every chapter, there are chapter review problems and chapter tests, practice tests for you to go through. And I encourage you to select the problems that are similar to what we see in the lecture. Okay. We discussed this yesterday. I will remind us that for these types of problems, when you're solving trig equations, there are a lot of details that we need to watch for. For example, we need to check, are we in degrees or radians? Do they want all solutions, or do we need to go further to get specified solutions? Also, check the plus or minus signs. Check that when you're working with cosine, you're looking at the x coordinate on the unit circle. When you're working with sine, we're looking at the y coordinate on the unit circle. Okay, so there are a lot of potential careless errors, but those can be prevented by checking our work carefully. Great, students, thanks for sharing in the chat. Okay, this concludes the recording for section 4.4. So I'm going to stop the recording for 4.4.